Hello and welcome back to Old Man and the Sea. Sharp. It's the final episode. It's the final lesson. This Sunday, lesson number 4, Sunday afternoon. Got one last little bit of thing to teach. And yeah, so we're going to do one last really quick lesson. And then what we're going to do after that is we're going to make a little game using all the lessons that we learned and try to make a fun 3D game using all these different things. One last thing that I wanted to show you before we got started, though, are arrays and loops. Two important things that we can work with. So to make our game in a little bit, I'm going to end up trashing all of our old stuff that we've worked on so far. But first, I'm going to show you what an array and a loop is. So remember our data types that we went over a few lessons ago on yesterday morning? We had floats and ints and strings, and we even added some rigid bodies this morning and text meshes and a bunch of other things. So all these different types, they hold one single value. And if you look back here at Unity, the representation of all these things, there's just a single value in each of these. But sometimes you want to store a list of things, like if you want to have a container for a bunch of enemy types, or if you want to make a list of all the trees in the world or something. If you have multiple of a single object, so let's say you want, let's say there's a bad guy in the level, and the bad guy has 1 hit point, right? And you look over in Unity. Come on, refresh. Take your time. Okay, there we go. Let me see, we have bad guy health. Bad guy has 1 health. But if we add a second bad guy, you have to go like bad guy health 2. If you add a third bad guy, or 4th, 5th, 6th, 7th, like this starts getting like really unwieldy, right? Like this works, you can do this, but you have to keep track of like, okay, am I damaging bad guy 3 or what's the deal there? And like this looks like a mess as well, right? Having to edit, you know, like, oh, this one's only at 30% health and this one's at, oh, these are integers, so they can't be percents. This guy's got 100 health and this guy's got 40 health, 49 health, right? Like this, obviously it's untenable. Like it might work if you have a small handful of things, but if you have like enemy swarms like coming in over and over and over again or something like that, right? Like you need a way to manage a collection of things. And the way that we indicate that in C# is with an array or a list or a dictionary, or they're all different data types that store data in different ways as a set. The base fundamental unit of that is an array, which is just a set that you kind of define up front. And the way I'm going to do that, as an example here, I call it good guy health, just as a differentiator for the bad guy health. See the little square braces I put here? That is saying that it is a set of integers. And what do we have? We have 7 bad guys, so we could put a little 7 in there. And now we know we have, oh wait, can we put a little 7 in there? No, we can't. I was lying. You put it on that side, like that. So that's saying that we have 7 good guy healths, right? But if we don't define this here, like we don't define any of these other variables down here, Save that, and we swap back to Unity. Let's see what that looks like. So you got the bad guy health all here, 1 through 7, and if you see good guy health, there's no value, but it has this little fold-out button. You click that, you see it says size is 0, so there's 0 good guy healths. Well, we want there to be 7 good guy healths. You hit enter there, and now we can see good guy health now has 7 elements starting at 0. And we can go through. We could be like, 70, 100, 0. There we go. And now we have a nice container for all 7 of the good guy healths in there. And we can shrink that down. We can open that up. So how do we access these values? Well, let's do a slightly different example. Let's say we want to change up the win message a little bit, just so I can make a working example that actually works in our project. So I'm going to delete those old things. And I'm going to take our win message, which right now is just a single string. I want to turn that into multiple strings. See, just put the little square braces there. That's the only change we're going to make. Save. Oh, and it's going to put an error where we're using our win message. I'm going to fix that in a second, but I'm going to comment that out right now so I don't have to deal with it just yet. Pop back over to Unity. And now we see our win message. It used to say winner here, and now it says nothing. And now I'm going to make it, I don't know, a size of 3. And I'm going to make it say winner, and you win, and hooray. There we go. So now we have 3 different win messages. And if we pop back in here, so how do we access these 3 win messages? Well, the first one, element 0, is winr. That's what we used to have, right? So all you have to do is just say back here where we used to be accessing the win message string, you just put the square brackets in again, and you put 0 for element 0. So the 0th win message, this is always going to be winr, right? So now we're back where we started. How do you access the first win message? Or the second win message. So if you put a 1 in there, that'll show element 1, and it'll say you win instead of winr. But the reason I was doing this is because I kind of want it to randomly pick between all of those different messages. So what I'm going to do here is I'm going to show you the random function, which is nice and fun. Okay, so string our win message is going to be, well, what we had before is win message 0, and then just get it back to our old state, our win message. This is just so we can edit it a little bit better and it's easier to see what's going on. Okay, so win message has a number of elements in it. And right now there are 3 elements, elements 0, 1, and 2, which we can see in Unity. But we don't know how many there will be forever. We know there's 3 right now, but I can just pop into Unity and quickly change it to 4. So we need to find a way to figure out how many win messages there are so that we can randomly pick one of those win messages. That's pretty easy. So this indicator here is called the index, like what's the element number, what's the element index. So I'm going to make a new integer called our selected index. That's going to be 0 for now. And I want to find out how many are in there. Num messages, the number of messages is going to equal win message. Now, if you're ever trying to find a property, again, you just hit the period key and see what auto-populates. You hit period, and look at that, there's length. So length tells you how long this structure is, how many elements are in this array. So now num messages represents that. So I want to pick a random number between 0 and num messages. How do we do that? Well, our index is going to become random, which is another Unity keyword you just have to memorize, random, and you just hit dot and see what random can give you. Random can give you a value or a unit inside a sphere or a random color, that's fun, all these things, but we actually just want the top one here, random range. And I want a random range, again, between 0 and, so if you look at the pop-up here, it says the minimum number is the first and the second number is the maximum number. And it says it returns a random float between the minimum number inclusive and the maximum number inclusive. So I'm just going to put num messages here. So now we can pick a random number between and including 0 and 3, right? But remember that there are 3 messages and they are indexed 0, 1, and 2, right? So we need our index to be 0, 1, or 2. Right now we're picking a number between 0 and 3 inclusive. So we're going to pick 0, 1, 2, or 3. That's there's 3 elements, but we might pick randomly one of 4 numbers, right? Does that make sense? If you just think it through, it'll make sense. It's because we have a 0 index instead of a 1 index. So we actually have to pick a number between 0 and the number of messages minus 1. So that way, if there's 3 messages, there's 3 messages, we're going to pick a random number between 0 and 2. That is 0, 1, or 2. That's 3 elements, right? You'll get used to, when you're programming, just doing -1 on a lot of different things. This is one of those little tricks that you'll learn over time. And now we have our number of messages is the length. Our index is a random number between 0 and the length, -1. And then our win message is going to be that index value from our win messages. Nice, simple, easy to understand. And now we can see here that we're just outputting our win message. Just give that a quick test. And it's still set to 20 for our goal. Let's drop that down to 3 for our goal again. And this should output our win message here in the console. 1, 2, 3. It says you win. So it randomly picked element number 1. And if we go again, 1, 2, 3, you win again. Come on, lucky number 1. 1, 2, 3, you win. Hopefully I did it right. Did I do it right? Is it just my good luck? You win. See, now I'm getting the same thing so many times in a row, I'm going to go and double check. Our win message. Yeah, no, I think I'm just having good luck. Always rolling the same number. 1, 2, 3. Winner! There we go. Got a different result that time. All right. So that's an example of a way that, a game might select a random footstep noise. So it isn't the same footstep noise all the time. You just have a list of footstep noises and you randomly pick one and then you play the noise. Or you show different dialogue for the same event. You could just kind of have a set of dialogue and you just randomly pick one of them. Or if you wanted to be fancy, we could print all 3 of them. And the way you could do that is with a loop. So I'm just going to show you, loops are handy for all sorts of different things. I'm going to show you an example of that when we make a game together in a few seconds here, a few minutes here. But for now, instead of displaying a random message like this, instead, let's do a loop. So loops are a structure kind of like, I don't know, an if or a function, because it has braces. And it lets you iterate over every element in one array. So let's say we want to say you win all the different ways as a proper celebration. Maybe there's a bunch of characters in the crowd all shouting you win in different ways all at once, right? The way we could do that is there's like three main types of loops. There's a bunch of ways you can do it. One of the easiest is a phrase called for each. And you could say for each, now our win message is a string, for each message in win message. And we could say debug log message. So what this is going to do is it's going to say for every one of the strings in win message, so remember there's three of them, there's like uwin, winr, and the other one, it's going to assign each of those to a temporary variable called message. And then inside this loop, we could do whatever we want with that particular string. We actually probably want to say plus, and then add our victory points to there just to add some consistency. And so we can see the separation. I'm just going to put some dashes in the output log. That's just so we can visually see what's happening here. And if we save this, we hit play. 1, 2, 3. Boom, you see all of a sudden, in here in the log, here's my dash, my first dash, and here's my second dash, which correspond to, actually here, I'm gonna show you side by side, look at this. So that first, whoops, didn't mean to click. That first dash there lines up with this first dash here, and then you can see this loop repeated 1, 2, 3 times. Said winner, you win, hooray. And that was all done by this here. So being able to loop over something or act on a set of things is useful. Like, let's say you throw a donut into a piranha tank, and the piranha tank has 7 piranhas, and each of them want to eat a little bit of the donut. Then you could loop through every one of the piranhas, and for each piranha, you can decrease the size of the donut a little bit, right? So yeah, loops are handy. We haven't really used them in our previous examples. There's other ways to do loops as well. One of the most common ones is a for loop. The syntax is kind of weird, but I'll show you. Is this the win message length plus? Now, one of the things I like to do actually is when you're making a set of things, name the variable with an S on the end, so it makes a bit more sense. Like win messages would have made a bit more sense. But for loop is very similar to this old for each loop we use down here. The difference is that a for loop is kind of an old classic, and it has this weird old syntax, but it's broken into 3 parts. And the 3 parts, you can visualize, you can put them on different lines so you can kind of visualize how they work. So we're saying we're declaring an integer variable called I. This could be anything. You can name it X or T or doobly-doo or whatever you want. I is the common one because it's an iterator. You're saying the iterator is going to start at 0. And then for as long as I is less than the length of the win message, so that is as long as I is less than 3 right now, then we are going to add 1 to I, so I plus plus, which is equivalent to I plus 1, right? So this loop is saying that it's going to count from 0 to 3. That's basically what this is just saying. I'm just going to count from 0 to 3. In fact, you can just write it like that, right? I is 0 until I is less than 3, add to I. So it's going to repeat this loop 3 different times. But we want it to be dynamic in case we add a message later, right? So we're going to do win message length. So this loop is going to repeat 3 different times. Usually all these things go on the same line, so I'm just going to put those back there. And now we can say debug log. We could say message number I is win message, and then we use the I, we use I that is incrementing from 0 to 3. That's the index we're going to access, which is similar to what we did down here, right? So in this one, we picked a random number between 0 and 3, and we just used that number. This time, we're going to do this for every number between 0 and 3, and that's represented by the I. And I just added some extra stuff here so that we could see message number blah is blah. And now if we run this one, so for loops are useful. Sometimes you want that counter so that you can do other things where you could do different math depending on the counter. But here we go. See, message number 0 is winner, message number 1 is you win, message number 2 is hooray. And that corresponds with element 0, element 1, element 2. So you can see it just looped through all 3 of those different messages. So there's different ways that you can use this. There's also a while loop, which is, it can also work. I don't recommend you use it at this stage in the game, but you could say something like while, this one's a bit more plain English too. Here, let's just delete this one. Let's delete this one. And let's say int, let's say random roll equals 0. No, float. Float random roll is going to equal 0. And I say while random roll is less than 0.1 or less than or equal to 1, then let's print a random victory message. So I'm not done, but just looking at this right now, knowing plain English, what do you think is going to happen? We have a random roll. It's a number that is set to 0. And we're saying as long as random roll is less than 1, which it is less than 1, it's going to print a random victory message out to screen. How many is it going to print? It's going to print infinite number. It's just going to go on forever because random roll will never not be less than 1. Nothing's modifying random roll. It will always be less than 1. So this loop will always happen. It'll happen so often and for so long that your computer will just spin on this little loop for forever and it will crash Unity. So this is one of the sources of big game crashing bugs or when your computer locks up, right? It's usually bugs that involve something similar to this because there's ways you can kind of lock in the system and make sure that it never exits. So how can we make this exit? Well, the easiest way is we can say down here at the bottom, after we display our message, we could say random roll equals 10, right? And if we do this here, now what do you think is going to happen, right? While the random roll is 0, so it's going to go. So while random roll is less than 1, so it's going to go. It's going to do all these steps. Then it's going to set random roll to 10. Then it's going to loop back around and it's going to say while random roll is less than 1, this is now false. So it's not going to run again and it's just going to exit out and continue on and your program will continue running, right? So this one will be fine. This is just going to display one random message. So maybe that's fine. But instead of just setting it to 1, I'm going to set it to, this is why I named it random range. I'm going to set it to a random range between 1 and 2. So it can pick a number, it can pick the number 0, 1, or 2. If it's less than 1, that's kind of 50-50. You know what? It can pick fractions. So I'm going to say if it's less than 0.7. Okay, so what I'm doing here now is I'm saying if the random roll is, print a random message as long as the random roll is less than 0.7, and then I set it to a random number between 0 and 1. This is effectively saying there's a 70% chance that it's going to print an extra message. And it's going to keep repeating this, and it's going to keep rolling and rolling and rolling and rolling. And what do you think? After like statistical probability, we might get 3 messages, maybe more, maybe less, but we're always guaranteed to get 1 because we start out with 0, right? Nope, did I lock it up? Did I mess it up? I think I messed it up. See, I locked up Unity now. So where did I mess up? What did I, it's random roll float, yep. Int that. Oh. Yeah, I see what I did. Okay. See, good to fail live on camera because now I have to open up my Task Explorer. I have to force quit Unity. I think it'll come back after a while. I think Unity has a catch in there if you let it go for a few minutes. But I made a boo-boo. And it's one of the first things I told you about back in the very first lesson. I forgot to put the F on the number. And I got caught on a very common little mistake that people make. But this is why I don't recommend using while loops, because it's really easy to make that mistake. Okay, now we got it back up and running. Let's see where the mistake was. So I set the random roll to 0, then I said as long as the random roll is less than 0.7 or 70%, so that's all fine. My mistake was here in the random range. I didn't put Fs on these. So Unity thought I was saying pick a random number between the integer 0 and 1. And if you mouse over, now that I've put the Fs in, you mouse over this and you squint your eyes and you read it, it says provide a minimum and a maximum float. That's fine, that's what I did. And then it returns a random float between min inclusive and max inclusive, right? So that's what we were expecting. That's what we wanted with the Fs. But if I remove the Fs, and now you mouse over it, it's going to say something slightly different. See if you can spot the difference here. Supply an integer min and an integer max. Not what we meant, but read the description. It returns a random integer between min inclusive and max exclusive. So it's going to pick a number between 0 and 0. So I just told it to pick 0. And 0 is always less than 0.7. So so this loop will never end, right? A little tricksy, little gotcha there. I don't know why it's exclusive with floats and inclusive with integer, or vice versa. I don't know why that is, but these are the little tricks. This is why programmers have secured careers for themselves for the rest of time, because we got to add little Fs to things all the time just to make sure our software runs correctly. Well, these are the little things, you know, like you're missing one little F somewhere and you got to look over your code until you find it. And a lot of this is just going to be trying to spot the dumb little mistake that you have somewhere in your piles and piles of code. But that's why you test constantly over and over and over again. Don't just go off writing code for hours and then try to run it. Like, try to run it as often as you can. Oh, and it moved my... Because Unity crashed, it didn't save my positions for my console. And it didn't save... Where's our script object? Oh, we still need 20 for the goal, so let's set that back to 3 again. Okay, try this again. It should work this time. 1, 2, 3. Look at that. It gave me 2 victory messages. There we go. That's better. And try again. 1, 2. Whoa, look at that. This time I got, what, 14. I got 14 victory messages. Wow, lucky. So you can see maybe you can do some like random particle effects or things like that. So I recommend don't dabble in the while loops. I recommend you stick to like that first one I did with the for each loop. Like that was much nicer, wasn't it? Yeah. So I was thinking, how about for the next half hour, it's just about the perfect timing for that. Let's see how far we can get making a little, I don't know, let's say we have a canoe on a frozen lake, as we have out here at our code camp. And let's see how far we can get turning that into a little game, right? Using just these simple things that we've taught on Saturday morning, Saturday afternoon, here on Sunday morning, and the lesson so far in this video. So let's close this. Let's close that. And let's do a really quick project layout. Oh, you can see it's actually split a game, and this isn't a standard layout. Let me switch back to the default layout. If your layout ever gets messed up or you lose a window or anything, up in the top right here, there's a button. You could change it to the default layout. I'll get you back to familiar territory. This is actually not very familiar to me because I've customized my layout in my day-to-day work so heavily that this doesn't make a whole lot of sense to me anymore, but figuring it out. Okay, so let's make this window bigger. Okay, so what are we going to do here? First, I'm going to get rid of these scripts that we spent so much work on. Remember, deleting things is always good in programming, always good. And I'm going to delete these two objects so that we're just left with a floor. And you can get some folks on your team to help you out with you know, what a material is and what you can do with that. But I'm going to set this to nice icy blue. Just drag that on the floor. Look at that nice shiny icy blue. Actually, I can make that really smooth, can't I? Look at that. Now it looks extra icy. Is that metallic? I'm going to say ice is 10% metallic. And let's make another material for our canoe. And the canoe is going to be, you know, canoe color, which is kind of gold, right? You know, standard canoe color. It's a little more flat and a tiny bit metallic. And is it emissive? Does this work? Whoa, yeah. Let's make it emissive. We have a glowing red hot. There we go. A glowing red hot golden canoe. Nice. You know, as you do. And now let's make a little. So let's make some labels. So this is going to be a canoe, and this is going to be the ice. 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 Lol. Okay, and then we need a start point, and I'm gonna make a goal. So we have something to strive for, right? So I'm just gonna stretch this ice out, and because we're gonna start here near the beginning, I'm gonna stretch it out that way, and then I'm gonna say down here at the end is gonna be kind of a goal line, right? So let's make a new cube. New tiny cube? No, let's make it bigger. New big cube. Whoa. Let's bring him over. Come on over, buddy. Come on, little buddy. There we go. And what I'm going to do is I'm going to call this the victory cube. And I'm going to leave it as a visible object for now, but I'm going to make it invisible later. So you just have to kind of get into the cube space. So I'm just going to make it invisible. Well, yeah, I'm just going to make it invisible by turning off the renderer, which I showed you earlier. And because it comes with a collider, it's going to act like the floor. You're just going to bounce off of it. I don't want you to bounce off of it, but I still want to be able to use the physics system to detect if you touch it. And the way you do that is you, down here in the box collider, you check off is trigger. Now that doesn't do anything by default except it turns off the collision event. So you can't clunk into things, but through code, you can detect if they're touching. So that way we can tell if you've passed through that the victory cube, right? But for now, we got our glowing red hot golden canoe. Let's make it look a little more canoe-y. Perfect, look at that. Looks like a perfect canoe now. Can you believe it? Holy smokes. And because it's a frozen lake, this red hot canoe should just fall down. So if I hit play now, we should see our red hot canoe just fall into the ice. And there we see our goal off in the distance. Nice, okay. Now, we wanna make sure that the player can always see their canoe as it scoots down the ice, right? So I'm just gonna kind of line up the camera to what I think feels kind of nice. And I'm gonna use a Unity function here to take the main camera. I'm just gonna select it. And you can see in the little preview, see the view is way different than what we're seeing here in the scene view. And you can see that if you switch over to the game tab, right? This isn't the view we want. We kind of want this kind of view. So what we're gonna do is when you have the main camera selected, I'm gonna say game object, and I'm gonna say align with view. And that moves the camera to align with the scene view that I've kind of manually set up. And now if I switch back to the game view, sure enough, camera's now kind of set up nice and neat behind the canoe. If you hit play, what do you think's gonna happen? The canoe just falls down and the camera doesn't follow it. And that's to be expected. There's a whole bunch of different ways you can solve that as a problem. The way I'm gonna solve it is I'm just gonna drag and drop the camera to be a child of the canoe. That's it. Nice, simple solution. And now when we hit play, what do you think is gonna happen? See, the whole camera falls down with the canoe. The camera just moves with the canoe because it's a child of it. So anything you do to the canoe is gonna happen to the camera too. Now we have a really cheap, really easy first-person camera or third-person camera controller, right? Nice. So we've almost got enough layout here to make a fun, like race to the finish line kind of canoe game. And we've written no scripting so far. And this is one of the reasons why Unity is so popular and so great a tool, because we can do things like this. Is you can mock up a lot of the game without even touching the code. So as much as you can, always do without the code to start. But we're gonna have to start adding scripts now. Namely, we need to move the canoe. So I'm gonna make a script here on the canoe. Instead of right-clicking down here, which is what I'd normally do, I'm gonna make a script another way, which is you select the canoe, you scroll down, and you say add component. And the component I wanna add is the canoe controller. You say enter, then you click create and add, and it will make a new script. You can see it here in your folder. It just created a new script for you. And if you look at your canoe, you can see your script is here on the canoe. Nice, perfect, great. Now, I'm gonna double click on this. It's the same as double clicking on this. Let Unity think. Don't know what it's thinking about. I don't know what it does. Sometimes it just says, you know what, I want to think about this. Why is it opening a new window when I already have one? Oh, I see. He was sitting here complaining about something. All right, so let's get started on writing some canoe controlling code. So here's our canoe controller. The start function is called exactly once. That might be useful for some things, maybe setting a player color or resetting your score or something, but we don't need it for this example. We do need the update loop because every frame of the game we want to affect the game world. We want to, add different things. But remember how we made the box jump? Remember we used the rigid body to add a force to make the box jump up? I want to be able to add a force to the canoe's rigid body to push it forward now. So I need a reference to the rigid body. So I know I'm going to need that. So I'm going to make that a public variable, canoe rigid body. All right, now I know I'm going to want to tune the different numbers for controlling the canoe. So I'm going to say, make a public float called canoe forward force and canoe turning force, because I kind of want to tune the controls of forward motion a little bit differently from the left and right motion, right? So that might be interesting to play with. What else are we going to need? I think we're going to need some extra things like countdown timers and victory messages and all that kind of stuff, but let's get to that later. Let's just get this canoe moving for now. So first up, we need to tell our script, right? It has no rigid body. We have to tell it what rigid body we want the canoe controller to control. I'm going to click that button and I'm going to say I want it to control the one on the canoe, right? And I don't know what I want the forward force to be. Let's say 10. We used 100 for the box, and it just went up that tiny amount, but we only hit it once. If we hold down the accelerator, I don't want it to be like and just like accelerate super duper fast, right? Or maybe I do, I don't know. So I'm going to make it a lower number, 10, and maybe I'll just make the turning force 10 as well. Hopefully those are good numbers, but we can always change them later. No big deal. Now, how are we going to tackle this? We want to probably keep this nice and separate in nice little functions. So I'm going to make a function called moveCanoe. Now I could do this in the update loop, but just to keep it more legible and like easy to understand and flow, I'm gonna kind of break it down into separate things. Now to move the canoe, I need to apply a force to the rigid body. So I'm gonna say canoe rigid body, and I forget the command, so you hit dot and you just take a look and add force, right? And I need to supply it a force value. And I'm going to have to figure out what that is. So how do we calculate the force value? Well, I think I'm going to make a function for that. Now, force is expecting, as you see in the mouse over here, it's expecting a vector 3 is force to add. So I'm going to make a function. I'm going to call it get keyboard intent. I don't know what that means. It means what is the player intending to do as indicated on the keyboard? And we're going to answer that question in the form of a vector 3, which is handy because that's what we need to force into the canoe here. So I'm going to say get keyboard intent, right? So nice, easy to understand so far. But we need to figure out what the keyboard's doing. We need to figure out how to translate keyboard inputs into a force. So there's a few different ways of doing this. Some are built into Unity. For example, you could say input.getAxis horizontal, and by default that will give you, if you mouse over it, it'll tell you, it gives you a float between -1 and 1 that represents your left-right motion. That's probably what we should use. In fact, maybe I will use that, but because it's kind of advanced, I'm going to show you what the equivalent of that is if we were to make it ourselves, right? So we can say Float forward motion is 0. So we have no forward motion right now. And we could say if input get key down, key code up arrow. So, or not get key down, we want to know if the key is held down, which if you remember back to lesson 1 or 2 is just get key. So input.getKey up arrow. So this means you're holding down the up arrow. Then we could say forward motion goes 1. So now if you're pressing the up arrow, then you'll move forward. Our float to variable forward motion becomes 1. And then we could do the same thing. We could do another if for the left arrow, and we could do another if for the right arrow. But all of this is kind of wrapped up in a function like this. So we could say turn motion equals, and float forward motion equals input get axis vertical. And it's complaining because I've defined it right here. Right, so might as well use the tools that Unity gave us. If you want to know, I'm going to show you real quick where to find like this axis name and what that means. It just comes by default with every project, and you can redefine those and configure them to be whatever you want. But you go up to Edit, Project Settings, you get this little pop-up. And here in the project settings, there's going to be one called Input. Yeah, Input Manager. And in here is axes. And you see they've predefined 18 of them for you, including like a fire button and a mouse wheel and all like a jump button. They've got all these different things already built in because many people commonly want them. But you could just erase all these, or you can redefine them yourself. I'm using horizontal and vertical, and if you open up horizontal, for example, you see horizontal is defined by the left arrow, the right arrow, but it also adds A and D in there in the mix. So you can use the WASD keys, and they do some other things too, like gravity and sensitivity and stuff like that. So it actually smooths out the input a little bit. And if you have a connected Xbox controller, it's gonna just take from all joysticks, it's just going to take the X-axis from the left stick. So using this horizontal little script, it does a lot for you. It just gets to the point and does all the things. But in the end, that's my slack. In the end of the day, what it's going to do is it's going to just do that same thing as we were doing earlier. It just outputs one number between -1 and 1. Like 1 if you're going forward, -1 if you're going backwards, or -1 if you're going left, or 1 if you're going right. If you don't touch anything, zeros, just zeros all the way through, right? So nice, easy, simple. Almost all the Unity tutorials will use the same thing. So if you go Googling Unity input or Unity input axis, it's going to just tell you all the same stuff. But now that we have a turn motion and now that we have a forward motion, we need to do something with that, right? We need to turn it into a vector3 because we want to turn that into input for our Canoe's add force system here, right? So let's make a new vector3 result. I'm going to call it result. And I'm just going to zero it out to start with. And I'm going to make the, the z-axis is going to equal our forward motion button. And our x-axis is going to equal our turn motion value, right? So where did I get z and x from? Well, if you open up Unity and you click on your canoe in the scene view, canoe, where are you? There we go. So here's our canoe. Oh, there we go. So see, our canoe is pointing towards the goal with the blue arrow here. The blue arrow, if you look in the top right, is the Z axis, right? And the red arrow, which is side to side, is the X axis. And Y is jump. So we can add a jump button if we wanted. Wow, I did it again. Let's open up. Yeah, so we could say float jump value equals 0, and then if input get key down key code space jump value equals 100, that's the cute jump value. And then we could say result.z equals the jump value. There we go. So now we just really quickly added a forward, back, left, right, and jump to an object. And all of that is just kind of collecting the input, and it returns it as a single vector3. And that single vector3, all we're doing with it right now is we're just adding it as a force to the canoe, right? So you notice I did get key down on spacebar. So if you hold down the spacebar, you won't just start flying. It'll just fire once. And then you have to lift your finger and press it again to jump again, right? So that's pretty good so far. We missed a step though. You know what? Let's make a public float canoe jumping force. So instead of just making jump 100, let's put in a variable, canoe jumping force. And that way we can modify that in the Unity inspector, which I'll do in just a second here. And here we have canoe forward force. We're gonna take, remember input.getAxis returns a value between -1 and 1. That's a nice value because that means we can now turn motion times equals, not forward force, that's a bug, turning force. And again, that's the equivalent of turn motion equals turn motion times canoe turning force. So now we're multiplying the value out by the number that we can tune in the Unity editor so that we can start playing with how fast we can move. We could say forward motion equals, or times equals, canoe forward force. Hopefully that'll make sense for you now. So this got complex really fast, but it's doing something very, very, very simple. And if we wanted to, we could split, the vertical calculation and the horizontal calculation and the jumping calculation all into their own functions just to split things up a little bit. But I think it makes sense to kind of combine them all into one singular keyboard input, right? So let's see how this feels. So here I am on the canoe. Here, if I scroll down, you can see I have forward force, turning force, 10, jump force. We want that to be 100 for the little cute hop. And let's see if it works. Let's hit play. Here we go. I'm going to press spacebar. Not working. Left and right works. Now I'm going to Barf City. Okay, so what did I... Jeez Louise, can I please quit Slack? Okay, so where did I mess up? Did I assign the jump value to Z? I did. I call move canoe. I've assigned this. I'm getting the value back. Result Z X. Oh, I did make a mistake. Can you see the mistake? I said result.z, result.x, and then I said result.z again. So I just overwrote the forward motion value with the jump value. Whoopsie-doo, and jump was nudging us forward instead of up. So let's change that to y. Y is the up vector. Okay, bug fixed. I'm glad I'm making mistakes on camera so we can kind of fix them together. Okay, boink, boink, there we go. Now we got a cute little hop running. If I mash the spacebar a whole bunch, then we can keep us flying. Oh, bonk. But maybe that little jump is a little too cute. Maybe we want it to be 10x bigger. So let's just change live right now. Let's change it to 1,000. No, it's too big. Now let's drop it down to 500. So this is how you tune a game in real time. It's a little floaty, maybe 300. That feels good, right? Yeah, that feels good. Now, when you stop the game, it resets the value to anything you change in play mode. It doesn't survive to the end of play mode. So you have to remember that was a good number. 300 is a good number. You set it now, and now it'll save, and it'll survive play mode. Now, I know rolling left and right is kind of broken, but let's see if the forward motion works. I'm just going to hold down W. Oh yeah, here we go. Woo! Okay, so forward motion is working. It's just kind of hard to tell how fast we're moving because there's no obstacles and we just have this kind of flat ground. So I'm just going to really quickly, I'm going to create a cylinder. It's like a tree, right? Obstacles. I make several of them. And just to organize them a little bit, I'm going to create an empty game object and move all of these obstacles into it. And then I'm going to duplicate that game object. And I'm just going to duplicate that again. And move it out here. Maybe I'll rotate it a little bit and I'll shimmy it over. I'll duplicate that one over here. And I'll duplicate it again over here. There we go. Now we've got a nice difficult little obstacle course to get through. And by default, cylinders all have colliders on them, so now we should see our motion. Woo! There, that feels a lot faster now, doesn't it? And we can see left and right works. Oh no, oh no. Oh geez, Louise. Oh, okay. So you see, it's really easy to roll the canoe. Ooh. Now we hit a thing. So we actually want the left and right motion to be a little bit different, and we don't want the canoe to roll over for this game. We only have a few minutes left, and we want to make it fun and not barf-tastic, right? So there's a few different ways to do that. First of all, I'm going to open up the canoe, and here in the rigid body, see in constraints, we can freeze the rotation or even the position in any axis. So what axis do we want? So roll, if we're looking at our canoe, and we're looking at these arrows. So roll or rotation is around an axis. So if you think about the green arrows pointing up, the canoe will rotate around that green axis. So that's kind of the fishtail, like car steering, right? The blue axis is pointing forward. The canoe will roll around the blue axis. So that's what we're seeing in the game right now is the canoe's rolling on the blue axis. And just for completion, the red axis, the canoe rolling around the red axis is going to tilt like going up and down a hill, right? So we want to stop the roll from happening and only the roll from happening. So that is the Z axis. It's the blue arrow, and we can look up here and see the blue arrow is the Z axis. So if we just say freeze the rotation around Z, problem solved. Now our canoe won't roll anymore. We hit play again. And now we can go forward, and I can hold down the left and the right arrow, and you can see that now when I press left, it kind of goes in this weird direction. I press right, it goes in this direction. Oh, why is that? Well, that's a common problem in Unity as well that people run into. Oh no! Okay, that looks kind of cool. I told it to freeze motion in this axis, but when you start rotating, that axis has now changed, and now you can start rotating forward back on a different, oh, it's complicated. So you know what I'm going to do? I'm just going to pretend I never clicked that. It's an option you can get into in advanced classes. You can sign up for the next camp, and we'll do that one. So I'm going to turn off the axis clamping on that. But I am going to fix it so that when we hit an obstacle, when you press left, your canoe goes left relative to the camera. It doesn't go left in the world, right? So the reason why it was doing that, and just to demonstrate that again so you can understand it, while I talk over the sirens. Oh, geez. Oh, geez. Oh, no, now I'm upside down. Okay, here's a good example. I'm going to press backwards, and you see it kind of rolled to the left. Why was that? Well, the reason is because if we look at the scene view, right now, the canoe is facing this way, right? It's going in this direction. If you press backwards, the canoe doesn't back up. The canoe goes backwards on the z-axis of the world, right? And the z-axis of the world is this way. It's back away from the goal area, right? So why is it moving in the world axis and not the local axis? Why is the canoe not moving backwards? That's because we told it to. Back here, when we said add force to the canoe, and the force was, so backwards is forward motion. Forward motion is just what are you pressing on the keyboard? So I was pressing the down arrow. The down arrow produces a result of -1. I multiply -1 by the canoe forward force, which is 10. So we have a value of -10. I then make a vector3 result, and I set the forward motion, which is result.z, to -10. Now, I feed result here into add force. Add force is in world space. Add force, the rigid body on the canoe doesn't know which way the canoe is facing. All it knows is the universe. So when you tell it to go -10, it will always go the same direction, no matter which way it's facing in the actual world. What we need to do is we need to translate our inputs to be relative to the canoe's facing direction. Sounds complicated, right? It can be complicated. If you're good at your maths and you're good at your vector math and you're good at 3D rotation, maybe this is easy for you. It's not easy for me. So I'm gonna show you a quick trick for that one, which is there is a cheat shortcut, which is transform.forward. And transform, we've seen that before. We haven't really done anything with it. Here in the canoe, the transform is the position, the rotation, and the scale of the canoe. That's the component we're talking about right now, right? So we could say, hey, our canoe's transform, what do you have available? You hit dot, and you can see we can get the current position of the canoe, which might be useful, or we can get the rotation or the scale. But what we want, if we scroll down, there's a whole bunch of things in here. I want transform.forward. Transform.forward is going to give me a vector3 that is forward of the canoe in whatever space it's in. But I don't just want it. I don't just want forward as a like I don't want forward all the time. I want to take that forward value and I want to multiply it by my forward motion. Now, there's going to be some red underlined squigglies for a little sec. So if you remember, forward motion is 1 if we're pressing on the up arrow, or -1 if we're pressing on the down arrow. And then we multiply it by our force, which is 10 right now, which we set in the editor, right? So it's 1 or -1, or 10 or -10. So if we take transform.forward and we multiply it by our forward motion, if we're not pressing any key, it's times 0, so it'll be 0. If we're pressing forward, it'll be times 10, so it'll be the local forward 10 units forward. If we're pressing backwards, it'll be the local forward times -10, which is backwards, right? So we want to take this result equals, or plus equals, this. So now we're saying the force we're going to add to the canoe starts off as 0, no force. And then we're going to add to that force a local forward vector 3 multiplied by our forward motion. And then that will give us a local kind of XYZ for that value. Likewise, we can say result plus equals transform dot up times our jump value, right? So now that's going to give us a relative up. So the canoe will always jump up. Even if we're upside down, the canoe is going to jump up into the ground. So come to think of it, actually, I don't think we want that, do we? We always want the canoe to jump up, no matter which way the canoe is rolled over. So I'm going to actually not do that. I'm just going to say vector 3 dot up times jump value, or we could say this is the equivalent of saying, well, we don't need this one anymore. So result dot y plus equals our jump value. So we'll keep that one safe, but we want our left and right motion to also be relative. So I'm going to say result plus equals transform dot left. No, is it transform dot right? Yeah, transform dot right times left is just right times -1. So you could just put a negative sign in there, and then that is turn motion. Right. So now we don't need this one, and now we have local relative space moving. Now, I know that one's a little bit more complicated and it requires you knowing 3D vector math and stuff like that, but just know these are common problems people run into. There's probably a million answers to this exact question on the internet on how to get local motion as opposed to global motion. Sometimes you want global motion, right? Like what if you're playing like a 2D runner and you always want forward to always be forward no matter which way the player gets turned around? Maybe that's what you want, right? Now I got forward and backwards. They still work as expected. I have left and right. So now, because right is relative, right is going to push me into the ground, and left is now my jump. Now I can fly because I'm on my side, and left is up in the air. But forward and back is still forward and back. And now jump, because jump is not relative, jump still bounces me up into the air, as well as left moves me up into the air, right? That's probably not what we want. That's probably not what we want at all. We don't want you to flip on your side and, yeah, I just double jumped over it. We don't want to flip on your side and jump up into the air. Now, I know this example is getting a little long, so I don't want to go into detail on how to fix that, but you can guess on how to fix that, right? Maybe you can take a look at the canoe's Z coordinate and not let left always bump you up. Or maybe you want left always to turn you left, to kind of like jump always goes in the same vector, right? The world is your oyster, however you want to solve that problem. But the thing I want to do before we go is I want to get a win screen going. So I'm going to add a 3D text object. And this is going to say win. Oh, you know what? I'm going to make it a UI object. Then I don't have to place it in the world. And it's going to say win. And it's going to say win over the whole flipping screen. So I'm not trying to teach you Canvas stuff, and I don't expect you to get that. So don't pay no attention to this. How's that for a nice big win message? Just cover the whole screen with win. Let's make a nice cheery color, like green for money. I'll make that centered. There we go. There we go. And if you flip to the game view, we'll see we have a nice big win message just plastered over our screen. Now we don't want that always there, so I'm actually going to disable the whole thing altogether. I'm just going to click this checkbox. Boom. It's disabled. And you can see it's grayed out in the scene view as well. So we know it's not active and it's not going to do anything. That's fine. We want to know how are we going to activate that? How can we show the player that it's going to be a victory? Well, Let's go to the scene. Well, we don't need the scene. We just need to click on the victory cube. Now remember we made the victory cube trigger so we don't bump into it. Here, I'll show you what it looks like if we bump into it. I turned off trigger. And now, whoop, double jump. That was a close one. And then clunk, right? We just bump into the wall. But we're in the editor, so I can click the checkbox now down here for is trigger. And now, if I go forward, see, I don't clonk into it anymore because it's trigger. What does is trigger do? Well, let's add a script to the victory box. And I'm going to call my script victory shower. You see it's made a new script for me and it's added it to my object for me. So if I double click on this, my victory shower, it needs one piece of information externally, which is I need to know what the victory message is. I need to know what the game object is for the victory message. And we go back over to Unity, and on the victory cube, you see now we have victory message and it says none and it wants a game object. I could click this, but it's going to show us every single little obstacle that we've added to the world now, and that's hard to pick through. So instead, I'm just going to drag and drop our victory message object right into here. It's our canvas. Now we have a reference to it. Now we just need to activate it at the right time. Now, how do you activate it? Well, the Unity physics system has a few different functions. So you know how it started us off with, It started us off with start, and it started us off with update as two functions that we can use. There's a whole bunch of functions that are kind of built in that it just doesn't pre-populate for you. And you can tell what they all are by kind of, they all come from this mono behavior. So you can kind of explore into this mono behavior by like holding down control and clicking on it. I'm not going to go into that, but if you're ever wondering what potential do I have? What can I possibly do with this game object? You just control click on this and it'll show you all the Unity options in there. But I'll tell you the one I'm interested in. There's two of them I'm kind of interested in. One is on collision enter. And the other one is on trigger enter. Now these are two built-in Unity things, and you could tell because anytime you type, like if I type my own function, see Visual Studio knows this isn't used anywhere. It grays it out because it won't ever be used. It says there's 0 references to it. But all of these 4, it says this is a Unity thing, right? These are all Unity things that are going to be used by Unity. So they will run even if we don't actually call them for anything. So what happens for these two? Remember when I bumped into the wall? That's a collision. So this function will fire anytime something bumps into it. Nice, simple. On trigger enter is the equivalent if you have that trigger text box checked, so you phase through it, this function will fire on that. So this is simple. Normally we'd say like, so the other here and the collision here, they tell you information about what collided with it. So you could say, oh, was this the canoe? Then win. But the canoe is the only moving object we have in the world, so we know it's going to be the canoe. So in this case, if there's a trigger, you say victory message, and dot, see what we have available to us. The very first suggestion it has is, do you want to turn it on? Yes, I do. Thank you very much. Set active to true. Super simple, right? Super duper simple. We're not going to use the collision one. Save that. So all we're saying is just turn on the victory message if anything triggers you. And we double check the victory cube. Oh, is triggers off. So turn that on. We want to make sure it's a trigger volume so that function actually fires. And now if we can make it to the end, it should say, you win. Double jump. Yeah. Bow, bow, bow. As we tumble to our doom. All right. Now you can imagine taking all of our old lessons, like maybe we can add a timer to this. Maybe you can add a high score, display that to the screen as well, right? Like the world's your oyster, do whatever you want. That's it. Done. You can all go home now. I release you back to your families. Thanks for joining me here on, gotta call up the, thanks for joining me on Old Man and the Sea. Sharp. And yeah, thanks for hanging out at my weekend code camp. Hopefully you went from zero programming knowledge to knowing a little bit about programming. Yeah. Goodbye.